An update on the Green Run hot fire test for Artemis 1, a commercial cargo spacecraft leaves the space station, and innovative ideas for exploring unexplored areas of the moon. A few of the stories to tell you about this week at NASA. The Green Run hot fire test with the Space Launch System or SLS rocket's core stage for our Artemis 1 mission is now targeted for as early as January 17th. The hot fire is the 8th and final scheduled test of the Green Run series and will see all 4 of the rocket's engines fire to simulate a launch. We conducted the 7th test of the series, the wet dress rehearsal, on December 20th. During that test, the core stage tanks were loaded with more than 700,000 gallons of supercold propellant for the first time and then drained. SLS will launch an uncrewed Orion spacecraft on a mission around the moon on Artemis 1. A Northrop Grumman Cygnus cargo spacecraft left the International Space Station on January 6th, more than 3 months after delivering nearly 8,000 pounds of supplies, scientific investigations, and other cargo to the orbiting outpost. The Cygnus is named in memory of Kalpana Chawla, a member of the STS-107 crew that was lost in the Space Shuttle Columbia accident. During a virtual forum January 6th and 7th, university teams selected as finalists in NASA's Breakthrough Innovative and Game-Changing or Big Idea Challenge presented innovative concepts for lunar payloads that could help NASA explore previously uncharted areas on the moon. Some of these concepts could help our Artemis lunar exploration program study the moon ahead of a human landing and help establish a sustained presence on the lunar surface. Researchers at our Kennedy Space Center recently tested a new robotic cube rover inside a massive bin of regolith rock and dust used to simulate the lunar surface. The shoebox-sized rover, built by Astrobotic Technology, was funded by a NASA program that encourages commercial development of innovative technologies to fulfill agency needs. As is the case with small satellites, the rover's standard size enables researchers and students to build and launch them on NASA missions designed to expand science, exploration, and commercial activity on the moon. NASA contributions to 2 recently approved heliophysics missions will help us understand the Sun and Earth as an interconnected system. One is an international mission targeted for launch in 2026 that will use a next-generation solar-observing telescope to study how solar wind and material is released from the Sun's atmosphere. The other mission will use a trio of small satellites to study electric currents in Earth's atmosphere, linking Aurora to Earth's magnetosphere. That mission will launch no earlier than June 2024. Data from our Solar Dynamics Observatory have led to new results about the workings of sunquakes, seismic activity seen as ripples on the Sun following a solar flare. Scientists have long suspected that sunquakes are driven by magnetic forces or heating of the outer atmosphere where solar flares occur. But data captured by SDO in 2011 saw surface ripples of a sunquake emerging from deep beneath the solar surface right after a flare occurred. Scientists now think that sunquake ripples are driven by a submerged source, which is somehow triggered by solar flares in the atmosphere above. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.